David, you've been running SimScale for a while. You're the co-founder and the CEO. We just started working with you about a year ago on Marc technology. Why now? Why are you excited about this partnership?
At SimScale, we work with thousands of engineering organizations to help them deploy simulation earlier, broader, more aggressively in pursuit of faster engineering cycles, more iteration in the same amount of time to ultimately innovate. And we've done this on a number of physics, on a number of solvers, really across a broad spectrum. But what was always missing so far is like capabilities around nonlinear material behavior and the likes. And now, as we've sort of stuff a lot of physics, in this point where we saw strong market saw the Hexagon team being very sort of seeing the same opportunity of actually being able to deploy this very capable nonlinear simulation technology much more broadly.
What got me excited is the way you're incorporating the agentic AI framework to help somebody who may never have done nonlinear.
One of the aspects that tell a user that is not running nonlinear simulations on a day-to-day basis enables them to use it effectively to start testing the technology. And one of the enabling technologies is we call it engineering AI. So agentic workflows where an AI engine starts not just predicting physics, but actually interpreting CAD, setting up the simulation, working through the simulation setup based on a certain guideline to the organization. Like a good example for Marc, let's see the crush test of a battery pack tutorial model. So we can see the stamp going down and you have certain energy that you're introducing in the assembly and you're interested in whether or not it can sustain it. And so of course, they could now import a simulation template. I could bring in from the use SimScale's process management capabilities to bring in an existing simulation template, or I can leverage the ability to now that transformer models are included in SimScale natively, I can ask the transformer model to actually do this for me. As we're seeing transformer models in other industries being picked up and reasons through intent and reasons through what it sees, it can use SimScale. So we're seeing it now applying the different contact setups. It asks whether or not it shall deal with the materials or not. So we'll ask it to do so. And again, you can see it's not a tuned one yet.
But I also like where it's pausing and letting you as the user do the guided assist to say, yes, you should continue.
And it's very much sort of now, because this is out of the box, what we supply out of the box. So it's a system that hasn't been tuned to any organizational workflow. As an engineering team, I would want the engineering AI to behave in a specific way, to be verbose or not verbose. So in this case, we're very much watching a junior AI engineer, but eventually one can see the potential. And so many industries, medical, automotive, bushings, fasteners, gaskets, you name it, is highly nonlinear on tech farming. And so the combination of the way we are able to deploy simulation broadly while maintaining central quality control, with Marc being able to solve nonlinear problems in a amount of time, with a level of robustness we haven't seen, gets us excited about the potential of that.
I didn't want to wait for the training. I said, no, I'm just going to start it myself. I was quickly able to get models from the library, take those models pre-configured, not even the pre-configured one, the regular ones, take it, do it myself, and launch it. So that's really the core I think that SimScale is bringing. And what's really exciting, being a nonlinear user myself for the last 2 decades, is what you said about Marc earlier, is that it's robust. If you talk to a typical nonlinear expert, the first question they'll ask is how much artificial damping you have. There's no artificial damping here because it converges out of the box. What's your feeling now that you've seen it?
We know that in order to make the simulation democratization initiative or a broad deploy or sort of a shift left initiative, engineering teams have different names. In order to make this succeed, yes, ease of use is key, and I would like to hear that you found it is ease of use. Collaboration is key, data management, HPC provisioning, those things are key to actually solve the engineering problem, fast, and robustly is key as well.
As I tested it, when can the work test it?
All of these examples here, they are snapped in production, so that's a development system where all of these simulations have been carried out in production. So this is live right now, but indeed, it's right now in beta mode with a selected set of early customers that help us give feedback. We have the first production launch in July. And so you can see already from the stuff we're demonstrating here initially is where the initial focus is, but much more will come. And then in typical SimScale manner, we're deploying dozens of times each week. So more and more simulation capabilities of Marc will be made available.
So in a sense, the convergence of AI, compute, physics is no longer a myth. It is a reality. And thanks for bringing this to our users and everybody at the board.
Yeah, thanks for having us.